Alright, so compared to spermatogenesis, oogenesis is a little bit tougher, and the reason being is because there's some odd timeline things to worry about. It is similar in a lot of ways, so we're going to start out with an oogonium, and that oogonium, the genetic material looks just like anything, skin cells, brain cells, stuff like that. So it is diploid, 2N, and just like the spermatogonium, it can go through mitosis to mitotically divide. And similar to spermatogenesis, once it makes the decision to go through meiosis, so we're going to write prophase 1 again, and once it makes that decision, it becomes a primary spermatocyte, or primary oocyte. So the important part here to keep in mind is that all of this stuff happens before birth. So that's a little bit different. The spermatogenesis process is happening throughout the male's life, and this stuff's a little more specific. So a woman is born with all of the primary spermatocytes arrested in prophase 1. So they're all stuck in prophase 1. They've decided to go through meiosis, so they are a primary spermatocyte, or a primary oocyte. And then once it goes to the next thing, it is going to become a secondary oocyte. But what's important here is that that's going to happen at puberty. So once we go from prophase 1, this is a primary spermatocyte, or primary oocyte. And our primary oocyte's still 2N because they haven't finished meiosis 1 yet. And then once the products, this is another difference between the two, the products of meiosis 1 here is going to be a secondary oocyte. And this is what we call a polar body. And so the reason polar bodies exist is because if you guys have seen pictures of like sperm and egg, eggs tend to be a lot bigger, and the reason behind that is they need more proteins, they need a lot of stuff, and so this isn't actually an equal division. Like here, when we went from primary spermatocytes to secondary spermatocytes, those were equal divisions. What's going to happen here is our secondary oocyte, we're going to make one of them, and it's going to take a lot of the proteins and the cytoplasm and stuff like that, and the polar body is just going to get lost, so it's going to die off. And the important thing to note here is kind of like this was before birth, this is all happening once a month once the woman starts puberty. So we're going to go from being a primary oocyte, it's still 2N, down to a secondary oocyte that's just N, and that's going to happen once a month during puberty. And then finally, there's another timeline thing to keep in mind. The reason we go from N back to 2N here is because when we go through meiosis 2, so this is meiosis 2, when we go through meiosis 2 here, this only happens if fertilization occurs. So the secondary oocyte would just leave the woman's body, but if it does get fertilized, then it's going to go ahead and go through meiosis 2. And this is obviously, we're going to just call this a fetus. And in meiosis 2, much like meiosis 1, this fetus is going to need a lot more of the cytoplasm, things like that. So because of that, we're going to make a secondary polar body. And much like the first one, this one's not going to be viable. So the products of oogenesis is going to be, depending, is either going to be a secondary oocyte, a 1N haploid secondary oocyte if fertilization does not occur, or it'll be a fetus if fertilization does occur, which is diploid. And then in addition to that, we make our primary and secondary polar bodies. So things to keep in mind on the difference between the two, the products, so spermatogenesis is going to make 4 sperm, and oogenesis is just going to make either the fetus or the secondary oocyte along with our 2 polar bodies, which just kind of dissipate. And then another thing to keep in mind is kind of our timing. So spermatogenesis, once you hit puberty, as males, this is going to pretty much happen for the rest of the male's life, whereas oogenesis, all of the oogonium and all of the primary oocytes she's going to have are going to be inside before birth, so she's not creating any more mitotically once she's born, and that's a lot different than the spermatogenesis in males. And then another thing to keep in mind, this isn't going to happen until puberty. So, and then unlike males where spermatogenesis isn't stuck on a time basis. It's just kind of always happening. For females, oogenesis, we actually create these secondary oocytes once a month. And then if fertilization were to occur, secondary oocytes go to the fetus, and then we're also going to create that secondary polar body. So that's the big differences between the two. Oogenesis is a little tougher, so be sure to look over that a couple extra times. But other than that, pretty simple stuff. So thanks. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts in this video are referencing material from this specific textbook. Remember, if you are a currently enrolled Baylor student, we offer free tutoring on the first floor of Sid Rich. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during normal business hours. For more information about our services, please visit our website, www.baylor.edu/tutoring. Thank you.